Hello Matrix and welcome again. So last time we did some derivatives and we looked at usually just the same notation, which was if dy over dx, like I've got at the top, find it if you've got a function y equals blah, 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 blah. So now I'm just going to show you some different alternative notations, which confuses people when it shouldn't, because really they're just asking the same thing. Okay, so for this first one, if you didn't see the last video, we're using what we use the power rule, but we need to get things into the way that we can use the power rule. So for this first one, y equals, I need to actually get this as x to the 3 over 2. If you're not sure how I did this, check out the video on exponents. I'll put a link in the description below now. And then the x to the 4 goes to the top and becomes x to the minus 4. Now I can use the simple power rule where I'm going to say dy over dx equals, and then 3 over 2 times 1 becomes just 3 over 2. And then I take 1 off the 3 over 2, which becomes a half. And then minus 4 times minus 2 is plus 8. And I take another 1 off the x to the minus 4 to become x to the minus 5. Let's just tidy this up a bit. 3x to the half, which I could also write as 3 square root x over 2, plus, and then 8 over x to the 5. So that's question 1, just to recap on how we use the power rule. Now, if you see this, f dash s of x, if f of x equals, okay, I haven't really, let me just make that x squared. What that means is just do the same thing. So for 2, I would just say f dash of x equals, and then the derivative of this, which is 2 times 1, which is 2, and then x, I take 1 off there. So when you see this, it's the same as finding dy over dx. Same thing here. If you see this, dx, x cubed minus 1x, this just means find the derivative of what's inside. So not a difficult question, but confusing if you haven't seen it before. So question 3, what we would do is we would just, we want to get this into the format where we can use this power rule, because you don't need to know the quotient rule, which is what you would use in AP Maths to find this. But you don't even need to even in AP Maths, because what happens here is when we factorize x cubed minus 1, we get x minus 1, and we get x squared plus x plus 1. If you're not sure, I'll put a link in the description to the video where I show how to find the difference or sum of cubes, how to factorize that. I'll put a link in right now if you want to check how I just factorize this x cubed minus 1 over x minus 1. These lovely, they cancel, and so now we find the dx of this, so find the derivative. So now we no longer need to write it as dx of this, because we've simplified it more. So now we simply just write equals 2x plus 1, because this is 2 times 1 is x. The 1 goes away. The derivative of x is just 1. Okay, so this question here, question 3, was more of an algebra question than a differentiation question. So again, something that you probably would have been familiar with in the younger grades. Next one, dy over dx equals, and they haven't put numbers here, they put letters, but we can treat letters like numbers, okay? So 2 times a is just 2a, right? And then if I take 1 off the 2, I get just 2x. So this becomes 2ax minus, and then the x here does not have an exponent, so the derivative is simply just 2a, because whatever is sitting with the x, that becomes the derivative if it's x without an exponent that is less than 1 or greater than 1. So if it's just 1, then we can just say 2a. Now the second one says dy over dA, okay? So when we do dy over dx, we treat the x as the thing that's you're finding the derivative of. If I say dy over dA, all I do is simply pretend that my a is now the x, and that my x, the x squareds are the numbers that are left. So this one here, 4 was this was dy over dA. Okay, I should have written dy over dx. Sorry. Now this one, I'm going to write dy over dA equals. Well, a does not have an exponent, so it's simply just x squared. In other words, say that this was written as x, or sorry, a squared x. Let me write it actually so it's not confusing. X a squared. So I'm going to underline this one in green. Okay, so all I'm doing is I'm swapping the x and a. So if you were to write dy over dx here, simple, right? X is by itself, so you just say the derivative is equal to a squared. Well, that's exactly what you're doing here. You're just saying dy over dA is x squared. The a is basically becoming the x. Okay, and so it's just a by itself, so the derivative will just be minus 2x. Okay, so I'm just going to put that green in there. So this is sometimes asked, it's not often, but if they say dy over dA, pretend the a is the x and find the derivative that way. So that last question, if it didn't quite make sense, you can just rewind the video and look at it again. The reason I brought that up was because it was in one of the past papers in 2019. And I thought it a little bit naughty of them to put that in because it's not something you would have seen before, but you are going to get these questions that you haven't seen before. And so, yeah, sometimes you just got to think, which is, yeah, that's what you got to do. All right, so hopefully that helped. If it did, please find the like, subscribe button down below and click it and all that good stuff so that you get notifications on when I do the next video. Next lesson, we're going to be doing cubic functions. So we're going to still be doing calculus, but now we're going to look at cubic functions, which is like a parabola, but it's to another power. So instead of getting 2 roots, we're going to get 3 roots, but we'll see how that works next lesson. Hope this helped, and I'll see you soon.